Welcome to Share Science. As spring is now upon us, we are going to talk about how snow melts and ways we can speed it up to help those spring buds come sooner. As the days get longer and the air starts to warm up, have you ever wondered why it takes so long for snowfall to melt and thought it needs to go quicker? Keep watching to find out how. Today, our experiments are going to explore how long snow takes to melt. So if you want to follow along, you're going to need a few things. First, you'll need something to record time, like a stopwatch, some snow, a bowl to keep it in, and a measuring scale to get consistent amounts. Here at Share Science HQ, we don't have any snow, so we decided to make our own with some ice chopped up really fine in a blender. You'll also need some additives to test. We tried salt, baking soda, and alcohol. Are there any others you can think to try? Once we have our equipment, we are going to learn two key things to help answer our question of how we can speed up melting snow. One, we need to understand what a melting point is and how we can affect a material's melting point by adding other materials. And two, we're going to explore what properties of these additives can help predict which are the best for melting snow faster. Here's our plan. First, we're going to collect fresh snow from outside, or create our own with some ice in a blender. Then we're going to weigh 15 grams of our snow on a plate and time how long it takes to melt without adding anything. This measure will act as our control to tell us how much of an improvement each additive makes. Then on separate plates, measure another 15 grams of snow and add 10 grams of each of our additives, and look what happens. Measure the time it takes each of these to melt and compare the results. Can you guess which one will melt the fastest? Feel free to try other additives and report your results in the comments. Here's a demonstration of our tests, which we've sped up 30 times since it took as long as 30 minutes for our snow to melt. Can you tell which test is melting the fastest? After only a few minutes, the alcohol test is really melting fast. Let's take a look at our results. We can take our measurements of melting times and summarize them in a table like this. We have a column indicating each additive, the time it took that sample to melt, and then a column comparing that sample to the control to indicate how effective it was. The baking soda was the least effective, only improving the melt time by 7%. When we look at the salt, which was discussed in another video linked here as a wintertime staple for melting road ice, it sped up melting by around 50%. But far and away the most effective additive we tried was rubbing alcohol, which improved melt time by 200%. Let's think about these results. To understand the effect that each additive has on melting snow, we need to understand how water freezes. Water, or H2O, is a unique substance that consists of molecules of oxygen, shown here in red, neighbored by two hydrogen atoms, shown in white. Water is an ionic molecule, meaning that each atom has a net charge that can interact with neighboring molecules. When water freezes, the positively charged hydrogen atoms are attracted to neighboring oxygen atoms and loosely bond to one another in a hexagonal formation through a process known as hydrogen bonding. Ice melts when we are able to break these hydrogen bonds, which allow the water molecules to flow freely past one another. If we break these bonds using heat, the molecules start vibrating more and more, and the temperature required to break the hydrogen bond completely is 0 degrees Celsius. In addition to heat, we can also use chemical means to melt the snow faster. Adding ionic materials like salt and rubbing alcohol can actually lower the melting point of water and get it to melt faster at a given ambient temperature. Let's take a look at how this works. As an example, when we add salt, or sodium chloride, to ice, the positive hydrogen atoms are attracted to the negatively charged chlorine instead of the neighboring oxygen, and the hydrogen bonds are broken. Similarly, the negatively charged oxygen atoms are attracted to the positively charged sodium. Another way to think of this effect is by comparing the melting point of each material. Salt water has a melting point of -20 Celsius, so when we add salt to water, we lower its melting temperature below 0 Celsius to be somewhere between 0 and -20, depending on how much salt we add. In fact, comparing melting points is actually a great way to tell if a material will lower or raise the melting temperature of water. For instance, the melting point of rubbing alcohol is actually -90 degrees Celsius, which helps explain why it works so well at melting ice. To summarize, we learned that to melt snow, we need to bring its temperature to 0 degrees Celsius. Water's melting point actually defines 0 degrees Celsius, just like boiling water defines 100 degrees Celsius. We can change this melting point by adding materials with different melting points to the water. Ionic materials, like alcohol and sodium chloride, help melt snow faster by disrupting the hydrogen bonding with their charged molecules, and we can use a material's melting point to estimate how it will affect snow. The lower the melting point, the faster it will melt the snow. While alcohol works the best of all the materials we tested, rock salt is a wintertime staple for melting road ice because it's easy to spread and adds much needed grit to your car's tires. We hope you liked today's video. Please like and subscribe to get more content just like this.